morning, everyone. This is our Launch Contingency News Conference from Vandenberg Air Force Base, and here to discuss what happened this morning with our Taurus launch with the Glory spacecraft is Omar Baez, the NASA Launch Director from the Kennedy Space Center, Ron Graby, the General Manager for the Orbital Sciences Corporation Launch Systems Group, Rich Straka, the Deputy General Manager for Operations from the Orbital Sciences Corporation's Launch Systems Group, and Mike Luther, the Deputy Associated Administrator for Programs for the Science Mission Directorate at NASA headquarters. And we'll begin first with Omar Baez. Omar?
Thank you, George. It's a very difficult situation we're in here, and I'm going to try to explain to you what happened last night and into this morning as far as the countdown and all the events as we got through them and what we know to this point. Last night our team came in at 10 p.m. to open up the checklist for the Taurus T9 Glory mission. We set up the facilities and the range, powered up the Taurus launch vehicle. We checked out the FTS system. We got through our polls. We got into the hot count. We encountered no anomalies with the spacecraft or the launch vehicle or the range in the whole count. At T-minus 5 minutes, we did our last poll, and we lifted off at 2:09:43 this morning, right on target. Stage 0 burned nominally for 1 minute and 25 seconds. Stage 1 then ignited, and a millisecond later we separated from the stage 0 and continued flight. We did that till 2 minutes and 45 seconds, where we had indication of burnout of the stage 1, and we had ignition of stage 2. About 6 seconds later, after a stage 2 ignition, we were expecting to see the fairing on the T9 separate. We didn't see the indication of fairing separation. There was other indications such as performance loss that we saw a little bit later on in flight, but we failed to make orbit. And all indications are that the satellite and the rocket is in the southern Pacific Ocean somewhere. And that's all I have for you.
All right, thank you, Omar. And now to Ron Graby, the General Manager for the Orbital Sciences Corporation Launch Systems Group. Ron?
Thanks. Well, let me just say this is a pretty tough night for all of us. A little over 2 years ago, we had a similar tough night when we conducted a Taurus launch for the OCO mission. That mission suffered a failure. The failure was a failure of the fairing to separate. We conducted an extensive investigation of that anomaly, and we traced the most probable cause to a failure of the fairing separation initiation system. We've spent the last 2 years doing the analysis on what went wrong that last time, redesigning the system and testing the components of the system. We went so far as to completely change out the initiation system to a system that we use on one of our other vehicles, the Minotaur 4 vehicle. And in the intervening 2 years, that system has flown successfully 3 times. So we really went into this flight feeling confident that we had nailed the fairing issue. And then we came up with the result that Omar described this evening. Let me just say that there's a great deal of emotional investment on the part of all the players on any space flight, but that's probably doubly so on a return to flight effort like this one. I'll just speak briefly to the the emotional state, if you will, of the team, and I mean the broad team, the launch team, the spacecraft team, on both the industry and the NASA side. I think it's not an understatement to say that tonight we're all pretty devastated. But we will recover. The team will bounce back because they're all professionals, and Orbital Sciences will bounce back with the Taurus vehicle. Let me turn it over to Rich Straka, and Rich will go through some of the differences between the system that we flew on OCO and what we flew here tonight.
All right, thank you, Ron. And Rich Straka is the Deputy General Manager for Operations for Orbital Sciences Launch Systems Group. Rich?
Okay. To give you an idea of what we changed, I'll just go through a brief description of what the fairing is and how it works. The Taurus uses a clamshell fairing, and the fairing is held onto the vehicle or constrained to the vehicle with what we call frangible joints. And those joints are meant to explosively fracture when commanded to do so. When the joints explosively fracture, the fairing is then in two halves, and there are piston pushers that push the fairing off. In the OCO vehicle and previous Taurus vehicles, we used what was called a hot gas system to do that pushing job. So there was a pyrotechnically initiated combustion process that generated hot gas, and the pressure of that hot gas pushing the pistons pushed the fairing halves apart. As Ron said, in the investigation, we identified the most probable cause of the OCO failure as a failure to initiate that hot gas combustion process. So what we did in response to that is we swapped out, or we changed out, redesigned the deployment system to use a cold gas system, which is a pressurized bottle of nitrogen that then, when commanded, functions by pressurizing those same pistons and pushing the fairing halves apart. It uses a completely different initiation system and a completely different pressurization methodology than the OCO system. And as Ron said, we really felt like we had the problem nailed, and that particular system has flown 3 times last year. A very similar system, almost identical system, flew in our Minotaur 4 product line successfully 3 times last year. So right now we're crunching the data, but there's really not enough data that's been processed so far to really tell any more than the fairing didn't deploy, and that's about all I have to say.
Thank you, Rich. And Mike Luther, the Deputy Associate Administrator for Programs for the Science Mission Directorate and NASA Headquarters. Mike?
Well, clearly, the Science Mission Directorate and the Earth Science Division is extremely disappointed in the loss tonight. We had worked closely at all levels of the agency and with our industry partners to evaluate this risk, and we felt going in that we believed we had an acceptable level of risk. Clearly, we missed something. So we've now got to go off, find out what that is, fix it, and that is, in fact, what we will do. In the meantime, we have lost the Glory mission. It would have made important measurements for the understanding of Earth as a system and of the impacts of climate change. However, the Earth SMD, the Science Mission Directorate, and the Earth Science Division will continue to contribute and make significant contributions to the understanding of the Earth with its 13 existing operating missions and a cadre of aircraft and ground networks and data systems contributing to Earth science research. In addition, we'll continue to plan the path forward into the next decade with a cadre of more than a dozen missions to be launched in the next 10 years.
All right. Thank you, Mike. And we're ready now for questions. Please give your name and affiliation when the microphone comes to you. We'll start here in the front with Nora.
Thank you. Nora Wallace, the Santa Barbara News Press. Omar, you said something about other indications of performance loss. Can you expand on that at all?
Yeah, what you see is, since we didn't jettison the fairing, you see, we're expecting to shed weight as the fairing comes off. And obviously, we didn't shed that weight, and the rocket just can't carry you into orbit with that extra amount of weight.
Janine Scully, Santa Maria Times, Lompoc Record. Can you, I know it's still early and you haven't thoroughly gone through the data, but can someone explain how similar this is to the OCO failure? Do you have indication of partial separation? Is there any kind of assessment that you can give in terms of OCOs?
I guess I can take that. We really don't have any of the data processed yet. It's going to be several hours before we get a good look at the data. So it's too early to tell whether it's the same thing as we faced last time in terms of the the symptoms and the data pattern. We just don't know right now. What I can say is that we did put additional telemetry points, and we do have additional instrumentation on this flight. So we do have a leg up on determining root cause this time, and but it's too early to tell if it is in fact the same cause.
Omar, are you going to be able to pinpoint more where the satellite might have ended up?
Yeah, we should be able to. It's just too preliminary to get the trajectory of where it ended up. But seeing that it's similar weight to what OCO was, and the same launch vehicle performance, it's likely, physics says it's likely in the same spot or close to it.
Can you explain, is there any kind of difference between the system that's been used on Glory versus what's flown successfully on Minotaur in terms of trying to figure what happened?
The fairing system itself is very similar, but they are different fairings between the two vehicles. They're different sizes for one thing. The Minotaur fairing is quite a bit larger, but it does use the same basic mechanisms, the same frangible joint system for the separation or the fracturing process, and the jettison system, the piston system, is almost identical. So, but there are differences in terms of the fairing size and the geometry of the fairing.
I wonder from NASA's standpoint if you can speak, maybe expand a little bit on how the Earth Science Group and the scientists here who've spent decades on this mission rebound from this, and how the crew might bond together in this to recover from this loss.
Well, as you mentioned, these missions are developed, as you well know, over a course of a number of years by some very dedicated people, overcoming great odds, and develop it really as a family. And so they respond to disappointments as a family would, quite frankly. And so I think if you can imagine how any family responds to a loss that might occur. They've overcome other obstacles previously. I'm sure they'll overcome this one, although it is quite painful after having dedicated so many years of your life.
Can you comment on the status of OCO2? Will it still use, the current plan is to fly on a Taurus XL? Is that, what's the plan now?
Well, OCO2 is in development, and a couple of years away from launch yet. We'll have to evaluate, the outcome of this investigation, and we'll adjust our plans appropriately.
Any other questions? All right, in that event, seeing none, that will conclude this briefing. Thank you very much.